The United States Air Force has once again taken a giant leap forward in modernizing its fleet, this time with the introduction of a brand new generation of $20 million supersonic trainer jets. Compact, agile, and purpose-built for the future of aerial combat training. These sleek aircraft, often dubbed Tiny Titan by aviators and insiders alike, represent a shift in how the U.S. is preparing its next generation of fighter pilots for the challenges of tomorrow's high-speed, high-tech battlefields. At first glance, the small size of these jets might fool the untrained eye, but make no mistake. These machines pack more performance, technology, and maneuverability into their compact frames than most fighter aircraft of previous decades. Designed to bridge the gap between basic flight instruction and full-on combat jet operation, these next-gen trainer jets are built with advanced avionics, fly-by-wire control systems, and the agility to mimic the flight characteristics of fifth-generation fighters like the F-22 Raptor and the F-35 Lightning II. As part of the U.S. Air Force's ongoing transformation under its Reforge and Pilot Training Next programs, these supersonic trainers are expected to reduce pilot training time, improve tactical readiness, and significantly cut operating costs compared to legacy platforms like the aging T-38 Talon. The replacement program, centered around aircraft like the Boeing Saab T-7A Red Hawk, marks the biggest shift in pilot preparation since the Vietnam War era. The T-7A, for instance, isn't just a fast plane. It's a flying classroom equipped with simulation-rich cockpits, embedded training modules, and network data systems that allow real-time monitoring and feedback. This means student pilots can train in complex missions such as aerial refueling, dogfighting, and electronic warfare, all within a highly efficient and cost-effective framework. What makes these $20 million trainer jets especially revolutionary isn't just their speed, which can exceed Mach 1, but their digital backbone. These aircraft are designed from the ground up to be reconfigurable via software, enabling instructors to simulate different aircraft performance profiles and threat environments without needing to change the hardware. Instructors can toggle between flight characteristics of an F-15, F-16, or even foreign adversary aircraft, giving students unparalleled exposure to real-world scenarios in controlled and safe setting. Additionally, maintenance crews are praising the new design for its modular architecture and built-in diagnostics, which allow for quicker turnaround times and improved aircraft availability rates. Perhaps most importantly, these trainer jets are laying the foundation for a more agile and responsive Air Force. With global threats evolving and peer adversaries advancing their air power, the U.S. can no longer afford lengthy training pipelines that take years to produce mission-ready pilots. These new trainers cut that time significantly while increasing the quality and depth of training, ensuring that the next generation of aviators is not only combat-ready, but digitally fluent and adaptable to the ever-changing face of aerial warfare. As tensions rise in regions like the Indo-Pacific and Eastern Europe, the need for rapid pilot generation is paramount, and these tiny supersonic trainers are the answer. Beyond training, analysts suggest these aircraft may also have secondary roles in aggressive squadrons, drone control operations, and even homeland security missions. Their speed, agility, and network connectivity make them ideal candidates for support roles in mixed force environments where larger jets might be overkill. Plus, their small size and efficient operation allow for greater deployment flexibility, especially in forward operating environments with limited infrastructure. Some military strategists even argue that in the near future, we might see drone wingman integration tested aboard these platforms, given their embedded computing power and secure communication systems. The rollout of these trainer jets has also reinvigorated interest in aerospace innovation across the American defense industry. Boeing, Saab, Lockheed Martin, and Northrop Grumman are all actively involved in pushing the envelope for trainer aircraft, each competing to provide enhancements, upgrades, and next-generation concepts to support evolving USAF doctrine. What we're seeing is not just a single aircraft platform entering service. It's a larger movement to redefine the entire ecosystem of how air dominance is taught, tested, and passed on to the next elite group of American warfighters. This includes AI-assisted training, VR-integrated simulators, and live virtual constructive (LVC) environments where real aircraft and simulators share the same digital battlefield. Public reception to the new trainer jets has been overwhelmingly positive, with footage of test flights going viral and attracting attention from aviation fans, defense analysts, and aspiring pilots across the country. The sleek red and white livery of the T-7A Red Hawk has already become iconic, paying homage to the Tuskegee Airmen while symbolizing a new era of excellence. Recruits entering the Air Force Academy now look to these jets not just as tools of learning, but as symbols of American speed, innovation, and readiness. In many ways, they represent a renaissance in military aviation, an era where form meets function, and where the next wave of airmen are being molded in machines worthy of their legacy. With the first full squadrons of these jets expected to enter operational service soon, training wings across the U.S. are preparing to transition to the new standard. Instructor pilots are undergoing conversion courses, maintenance crews are being retrained on the new systems, and simulators are being installed at bases from Texas to Arizona. The Air Force has made it clear, this isn't a trial run, it's the future. And that future flies faster, trains smarter, and strikes harder than ever before. These tiny supersonic trainer jets may be small in stature, but they are towering in their importance to the mission of American air superiority. They are the sharp edge of the spear, shaping the warriors who will own the skies of tomorrow. The rollout of these cutting-edge trainer jets continues to spark major developments across Air Force training commands and beyond. As squadrons begin to receive their first operational aircraft, there's a palpable energy on base flight lines from Vance to Laughlin, where student pilots eagerly line up for a chance to step into the cockpit of the future. One of the standout advantages of the $20 million tiny supersonic jets lies in their unmatched ability to scale with the evolving demands of next-gen warfare. These aircraft aren't just bridging a gap. They're creating a whole new flight regime where adaptability is king. Their modular training software allows USAF instructors to modify mission parameters on the fly, tailoring each flight session to match both trainee skill levels and real-time intelligence from the battlefield. Instructors can seamlessly transition a training scenario from simple formation flying to complex threat evasions based on simulated radar locks, aerial engagements, and electronic jamming, all without ever leaving the airspace. Furthermore, real-time telemetry from these jets is streamed directly to ground stations, allowing for live feedback, instant after-action review, and collaborative debriefing sessions with AI-assisted analytics. This leap in training efficiency represents more than just a cost-saving measure. It redefines a learning curve for fighter pilots and ensures that American aviators enter combat with an unmatched level of readiness. Another major benefit of these supersonic trainer jets is how they're enhancing international training partnerships. As allies and partner nations witness the transformative potential of these aircraft, several countries are exploring joint training initiatives and even procurement options. Australia, the United Kingdom, and several NATO allies have expressed interest in observing or adopting similar platforms. The possibility of integrated coalition training programs is very real, offering a strategic edge in joint operations and interoperability during multinational air campaigns. The trainers can be easily integrated with allied simulation networks and tactical data links, ensuring seamless collaboration in joint exercises and potential real-world contingencies. Additionally, these jets provide a perfect testing ground for new technologies and tactics. The Air Force's innovation arms, such as AFWorks and the 59th Test and Evaluation Squadron, have already begun using them to experiment with machine learning pilot aids, semi-autonomous navigation, and man-unmanned teaming concepts. By embedding digital interfaces and data fusion capabilities, these jets are also helping define how future sixth-generation aircraft like the Next Generation Air Dominance, NGAD, system will operate in sync with human pilots. These trainers are no longer just stepping stones. They are platforms of experimentation, acceleration, and integration. As operational tempo increases globally, the need for sustained readiness among pilots has never been greater. These new supersonic jets are helping the Air Force reduce pilot burnout and maximize sortie generation. With improved safety systems, reduced maintenance downtimes, and built-in mission debrief tech, student pilots and instructors can fly more often with less risk and fewer delays. This means more learning in less time and more capable pilots cycling to the pipeline faster than ever before. The jets also support a wider array of body types and pilot gear, improving inclusivity and safety standards in pilot selection and retention. Meanwhile, aerospace engineers and defense analysts continue to marvel at the sheer sophistication of these platforms. The fuselage design emphasizes high lift-to-drag ratios, while the engines are optimized for both supersonic burst and extended endurance, critical for long training missions or surprise high-speed intercept simulations. Pilots praise the cockpit ergonomics, which mirror that of fifth-gen fighters, complete with panoramic displays, voice-activated controls, and helmet-mounted targeting interfaces. These features are not only training pilots for today's skies, but preparing them to step seamlessly into the cockpits of tomorrow's warboats. On the home front, the arrival of these jets has had a profound impact on recruitment and public engagement. High school and college ROTC programs have reported spikes in interest as potential recruits are inspired by the sleek imagery and cutting-edge missions associated with these trainers. The Air Force has also leveraged the excitement around these new aircraft in digital campaigns and flyovers, creating an aura of prestige around the program and drawing top-tier talent into the pipeline. Museums, air shows, and STEM education events have all benefited from showcasing these remarkable aircraft and the young airmen and women who fly them. Looking ahead, the Air Force plans to expand the trainer fleet to include a full digital ecosystem, connecting aircraft, instructors, simulators, and mission planners into one seamless operating network. The long-term vision includes using these jets as proving grounds for AI co-pilots, network combat clouds, and real-time battle management systems. In essence, these tiny supersonic trainers are not just teaching pilots how to fly. They're teaching the Air Force how to fight smarter, faster, and more cohesively in an era defined by speed and information dominance. The introduction of these aircraft is a testament to American innovation, adaptability, and military foresight. They may be small in size, but their impact on the future of air combat training is enormous. Every sortie flown in these jets brings us one step closer to building an Air Force that's not just prepared for future, it's already flying in it. As the U.S. Air Force continues to integrate these state-of-the-art $20 million tiny supersonic trainer jets into active service, the strategic implications extend far beyond just pilot education. One of the core tenets of their deployment is adaptability, not just in terms of how pilots learn, but also how the military responds to emergent threats. In real-world conflict zones, the margin for error is razor-thin, and these trainer jets offer an unprecedented edge by simulating high-threat environments with uncanny realism. Through embedded threat emulators, the jets can replicate radar pings, missile lock warnings, and even multi-band electronic warfare signals, conditioning pilots to operate under the kind of psychological and tactical pressure found only in hostile skies. This exposure prepares them mentally, emotionally, and tactically for the dangers they may face during combat missions with fifth or sixth-generation aircraft. Moreover, the adoption of these jets is feeding into the broader modernization blueprint of the U.S. Air Force. The Department of the Air Force's 2030 vision leans heavily on technology convergence, where AI, cyber warfare, electronic warfare, and advanced aviation platforms operate in tandem to achieve information superiority and air dominance. These trainers function as experimental hubs, allowing test pilots and researchers to trial multi-domain tactics, test secure communication protocols, and experiment with cloud-based mission planning systems. This positions the Air Force to rapidly iterate, test, and field innovations without needing to divert active combat aircraft from global taskings or high-value readiness cycles. Perhaps one of the most remarkable aspects of these jets is how their arrival is reshaping the culture of pilot training itself. The rigid hierarchy and doctrine-driven instruction models of the past are giving way to a data-driven, feedback-oriented ecosystem. With every training mission logged and analyzed in fine detail, instructors now rely on performance heat maps, biometric stress readings, and in-flight AI coaching indicators to personalize instruction. For example, if a cadet consistently overcorrects during banking maneuvers or reacts slowly to radar threats, the next simulator or in-air lesson can specifically target those weaknesses using data overlays and real-time correction feedback. This quantum leap in personalized pilot development isn't just a luxury. It's a necessity for grooming elite aviators who can thrive in future combat scenarios where decision cycles are measured in milliseconds. Further fueling the excitement is the dual-use potential of these aircraft. While their primary mission is pilot training, they're increasingly being tapped for secondary operational roles, such as adversary air support, homeland defense simulations, and even reconnaissance training. Lightweight, fuel-efficient, and capable of rapid redeployment, these jets can be forward-staged at Allied bases or aboard aircraft carriers equipped with smaller runways. Their portability and low operational cost make them ideal for expanding the U.S. footprint across the Indo-Pacific and Europe without triggering the same level of geopolitical tension that comes with deploying full-scale combat aircraft. This makes them not only a training asset, but a diplomatic and strategic tool in America's broader military posture. In the realm of research and development, these jets are proving to be the ideal testbed for autonomous flight algorithms. Teams from MIT, DARPA, and AFRL Air Force Research Laboratory have already conducted joint trials using these aircraft to refine man-unmanned teaming operations. These experiments involve pairing a human pilot in one jet with a ghost wingman, an AI-controlled jet that learns and adapts to machine learning while flying in formation, responding to commands, and participating in mock combat scenarios. These tests lay the groundwork for future air campaigns where human and AI pilots operate side by side to overwhelm adversaries through coordination, speed, and intelligence. The defense industrial base is also benefiting significantly from this program. Manufacturing contracts tied to these jets have helped sustain and create thousands of jobs across key aerospace hubs in the U.S., including in Texas, Missouri, and Florida. Advanced composite fabrication, engine development, avionics integration, and digital cockpit technologies are being developed and refined at a scale that stimulates innovation across both military and commercial aviation sectors. Small businesses, in particular, are finding new opportunities through modular software and hardware integrations that plug directly into the jet's open architecture systems. This synergy between defense and commercial tech ecosystems is accelerating innovation on a national level. Simultaneously, the international community is closely observing the rollout of these jets, with many allies seeing them as a model for modern military aviation. Japan, South Korea, Israel, and several European partners are considering similar acquisitions or collaborative production lines. The potential for joint ventures and technology sharing agreements not only strengthens diplomatic ties, but helps synchronize allied training standards and procedures. As a result, coalition forces will be better prepared to operate as a cohesive unit in future joint operations, reducing friction and increasing combat effectiveness. From a logistical standpoint, these jets are redefining the concept of maintainability. Their modular systems mean that key components, such as avionics modules, radar systems, or flight control units, can be quickly replaced or upgraded without taking the aircraft out of service for extended periods. Ground crews can complete turnaround maintenance in record time, keeping jets mission-ready and increasing training throughput across air bases. Built-in diagnostics and predictive maintenance tools further enhance their uptime, alerting crews to potential failures before they occur and streamlining the supply chain with real-time parts requests. In an era where adversaries are aggressively advancing their military capabilities, the U.S. cannot afford to lag behind in preparing its pilots for the battles of tomorrow. These $20 million tiny supersonic trainer jets are the very embodiment of smart defense spending, delivering unmatched performance, innovation, and training realism at a fraction of the cost of deploying high-end fighters for training roles. By investing in speed, modularity, and digital integration, the U.S. Air Force has taken a bold step forward, not only in its training pipeline, but in its overall strategy to deter, defend, and dominate. As the skies grow more contested and the pace of technological change accelerates, it's these compact marvels of aviation engineering that will quietly but decisively shape the next generation of American air power. They are proof that size isn't everything. Capability, foresight, and agility win wars. And in the hands of tomorrow's Top Gun aviators, forged in the cockpit of these jets, America's future in the air is not just secure, it's supersonic. And as the rollout of the U.S. Air Force's new $20 million tiny supersonic trainer jets enters its final implementation phase, the full spectrum of their capability is being unveiled across various missions, exercises, and experimental initiatives, solidifying them not only as critical training platforms, but also as multipurpose assets driving the future of American air dominance. These aircraft are now actively participating in red flag and green flag exercises at Nellis Air Force Base, where they go toe-to-toe with aggressor squadrons in full-spectrum combat simulations. Their role in these war games is crucial. They inject realism and complexity into training environments that push both instructors and students to their cognitive and physical limits. Their supersonic agility and radar evading profiles are mimicked to simulate enemy fifth-gen fighters, giving warfighters the closest experience possible to actual adversary engagements without risking billion-dollar platforms. At the same time, tactical data collected during these exercises is looped into centralized command networks, contributing to a constantly evolving database of threat modeling, pilot behavior analytics, and platform performance metrics that inform everything from mission planning protocols to procurement strategies at the Pentagon level. On a strategic scale, these jets are proving to be game changers in the shift toward more distributed and agile combat air force. Their relatively small footprint and minimal infrastructure requirements make them ideal candidates for Agile Combat Employment, ACE, the Air Force's strategy for dispersing combat power across forward operating locations to reduce vulnerability from long-range missile threats. With minimal ground support, these jets can take off from remote airstrips or allied bases, operate under decentralized command, and even integrate with joint force logistics through cloud-based mission updates. That level of flexibility aligns perfectly with 21st century warfare demands, where unpredictability, rapid deployment, and resilience can be more decisive than raw firepower. Back at home, Air Education and Training Command, ATC, is hailing the program as a revolutionary leap in pedagogy. The days of chalkboard theory and limited sim time are long gone. Today's cadets are experiencing fully immersive, VR-integrated training environments that are synced directly with the aircraft. With wearable sensors that record neurological responses, G-forces, eye tracking, and even emotional data under stress, instructors can debrief student performance with unprecedented clarity. In one instance at Laughlin Air Force Base, instructors use this data to detect a pilot's cognitive overload during an evasive maneuver simulation, then adjusted his curriculum to focus on cognitive load management under extreme acceleration. That kind of proactive, data-driven instruction is setting new global standards for flight schools. The geopolitical implications of this program are also not lost on America's adversaries. Reports from intelligence sources suggest that both Russia and China have scrambled to replicate similar trainer technologies, pouring billions into indigenous development projects. However, what they lack, and what the U.S. possesses in spades, is a synergistic innovation pipeline that ties together academia, military research, private sector contractors, and combat veterans into a single cohesive framework of iterative design and deployment. China's JL-10 and Russia's Yak-130, while impressive on paper, don't yet offer the same open architecture systems or AI-assisted feedback loops that the U.S. trainers are now known for. More importantly, their training doctrines remain rigid and centralized, contrasting sharply with the U.S. model of empowering squadron-level autonomy and individualized pilot development. As NATO partners express growing interest in joining the training ecosystem, the United States is exploring options to establish joint multinational flight schools using these jets as common platforms, fostering greater coalition interoperability and reducing the learning curve during joint operations. These initiatives are already being mapped out in Italy, the UK, and the Indo-Pacific region, where local air forces will provide infrastructure while the U.S. supplies trainers, instructors, and the aircraft themselves under joint funding agreements. Meanwhile, U.S. legislators and defense committees have taken notice of the program's success, with increased budget allocations being proposed in upcoming defense spending bills to expand production lines, accelerate procurement timelines, and develop next-generation variants with increased autonomy and stealth coatings. There's talk of a Block 2 version of the trainer that could include optional afterburning engines, upgraded composite skins for radar signature reduction, and plug-and-play mission pods for electronic warfare, reconnaissance, or air policing roles. That level of scalability is almost unheard of in trainer-class aircraft and reflects a strategic pivot toward dual-use platforms that can adapt alongside emerging threats and technologies. Another emerging use case is in unmanned teaming scenarios. With the push toward loyal wingman programs and drone swarms in full motion, the supersonic trainer jets are being used as piloted surrogates to test man-unmanned mission coordination, allowing fighter pilots to practice directing autonomous drones during live sorties. At a recent demonstration at Eglin Air Force Base, 2 trainer jets successfully orchestrated a simulated attack formation using AI-powered drones as decoys, electronic warfare jammers, and forward scouts, all controlled through a helmet-mounted interface inside the cockpit. The test was deemed a breakthrough moment, offering a glimpse into a future battlefield where a single human pilot could command an entire digital fleet in real time. Even maintenance and sustainment chains are reaping the benefits. With advanced 3D printable parts, predictive maintenance algorithms, and self-diagnosing onboard systems, ground crews report significantly reduced downtime and greater mission readiness. In fact, the jets have achieved over 95% availability rates in initial deployment trials, an astounding figure that rivals even modern frontline fighters. The reduction in lifecycle costs, combined with mission adaptability, is redefining how defense planners think about value per flight hour. And perhaps most importantly, these jets are inspiring a new generation of pilots. Social media campaigns, recruitment drives, and air shows featuring the new trainers has sparked a renewed fascination with military aviation among young Americans. With their sleek profiles, cutting-edge cockpits, and supersonic roars, these aircraft don't just represent training tools. They symbolize a future of strength, innovation, and air superiority. In every sense, they are the perfect blend of performance and purpose. As they soar through American skies and over Allied territories, these $20 million marvels quietly prepare warriors for the most complex combat scenarios the world has ever seen, embodying the ethos of force that never rests, never stops improving, and never surrenders the high ground. The world is watching, and the message is clear. The U.S. Air Force is not just training pilots. It is building the future of air power, one supersonic sortie at a time.